In this section, we will be interpreting the slope of a linear function. Now, the slope is the change in the output over the change in the inputs. So the units of the slope are going to be the output units, the units of the output variable over the units of the input variable. What we're creating is a rate of change. The slope is, in essence, a rate of change of the output with respect to the inputs. So when reading the units of the slope, it's going to be the output units per one single input unit. It is a rate of change of the output with respect to the input. So, for example, let's write an extra example in here. If the output of your function is, let's just say, height, measured in feet, and the input is time, measured in seconds, then the slope would be output units per input units. So feet per second. So if, for example, you knew that the slope was -5, your interpretation of that would be that the output, in this case the height, is decreasing. Whenever you're interpreting the slope, you have to indicate what the sign means. So the height is decreasing at a rate of 5 feet per second. If, for example, you knew that the slope was 3, a positive 3, your interpretation would be that the height is increasing. Again, you have to indicate what the positive slope tells you with regard to the output. So the height is increasing at a rate of 3 feet per second. So that is how you would interpret the slope of a linear function. The slope is always going to be a rate of change. So here in example 1, we have a graph that shows the amount of water in a tub over a 10-minute time period. So looking at this graph, the input variable, remember that the input is always plotted along the horizontal axis. So looking at the graph, we know that the input variable is time measured in minutes. The output variable is the amount of water. Measured in gallons. And those are two things we have to be able to figure out before we can answer any of these questions. So part A is asking you for the vertical intercept. Looking at the graph, the vertical intercept is the ordered pair 0, 40. Interpreting this, remember you have to interpret both of these coordinates. The 0 means that after 0 minutes, the input is measured in minutes, there were 40 gallons of water in the tub. All right, any interpretation has to include interpretation and units for both of the coordinates. And the same for the horizontal intercept. The horizontal intercept is 10, 0. You can get that just by looking at the graph, the x-intercept. So after 10 minutes, there are 0 gallons. Remaining in the tub. And there's a number of ways to do this. You could say after 10 minutes the tub is empty, but somehow indicating that you understand what both the input and the output value represent with regard to the water in the tub. Now coming to part C, the slope. It says determine the slope and interpret the meanings. So first we need to determine the slope. So there's y2 minus y1 over x2 minus x1. And looking at our ordered pairs, I'm just going to call this x1, y1, this x2, y2. So 0 minus 40 over 10 minus 0 gives us negative 40 over 10. Simplifying that down, we have negative 4. And the units are going to be gallons per minute. Interpreting this, the output, in this case it's the amount of water, is, remember we have to indicate what the sign means, so the amount of water is decreasing at a rate of 4 gallons per minute.